MMCD 5813, which is our class for computer-aided engineering, which is a very important class for the Master in Mechanical Engineering here at UTEM. So I have posted some videos from previous lectures for you to go through, but for this afternoon, we will focus on what will come in the test. And I will also make the project very much related to the test, so that you can utilize it or can prepare yourself for the test. So if you can do the project, I think inshallah you can do the test as well. So
how are you, Doctor?
Good. Mr. Al-Furjani, Ahmed Al-Furjani.
Yes.
Furjani or Furjani?
Al-Furjani.
Al-Furjani.
Yes.
Okay, so let me start sharing my. Before that, want to say.
قلت نقرا يا صهيب وش انت بتعال شو انت خلينا نقرا صهيب
يا عبد الرحيم صوتك واضح.
Let me share something.
ما عرفت كيف النحاس قلت يا احمد
Do mute.
للميكروفون يا احمد.
صحيت هذا وانت فاهم سكرته خلاص.
So you want to turn off your
microphone? الميكروفون والكاميرا ديما close when you want to speak.
Okay. Doctor, if you want to speak, you can turn on.
Yes. We heard you now.
All right. That's cool. Thank you very much. Okay, so I just shared the latest one, the reference for the things that will come up in the test. So if you want to focus on that, that will be much better. And from that information, I will focus on further, so that because we have only 2 hours for the test, and we will make so that you just focus on that those particular topics, so that you can do well in the test. All right. Okay, let me share my screen. If I can do that. Okay, over here, share my screen. Entire screen. This one, share. And I think even for myself, I can turn off my video. Okay. Can you see my screen? Can you see what is on my screen? Okay, that's cool. So
and even we can see you. Yeah, now we can see you. No, now it's okay.
Yes,
you can see only your screen.
All right, my screen. So before I go to the good stuff, yesterday, last night, I created this thing. I guess it's kind of like what we use in the lab last Tuesday. We created something like this, but the shape is a little bit different. Let me make this easier to see. Maybe Okay, maybe this one will be easier to see. So change the appearance, and all right, for yesterday, last night I tried to do the analysis for flow. So next week, Dr. Shukri Zakir will talk about the flow more deeply or more in more detail. And this one, that time he will use ANSYS. So it's supposed to be more accurate. But if you want to get some rough idea in the future, you can also look into this thing using SOLIDWORKS. So here I have, you can go to add in. So under here, I can turn on we have simulation here. Motion is good, but flow, where is flow? So should be flow available here, this one. So it's already turned on. That's why we have flow in one of the tab. So I'm gonna click OK there and click on flow. So after you have done created your wing, so you can go to flow tab. When we want to create this, we have to click sketch and then features. Then this time we click on flow simulation. If you want to do the stress analysis, you go to simulation only. So here last time we did the study, and I guess in the video that I shared in Ulen, I also did this thing on this one. I guess there is this one. If I on the bottom here, if I click on static, maybe there is still can still click on this one. Can I see activate? Maybe if I click on that, okay, so I'm gonna stop that, and so now we want to go to flow. Back to model. We want to do the flow. So flow, if I want to create a flow study, I can click on the wizard and give it a name here. I want to call it project number 3, because before this class I created project 2. Then I can click on next in this box, and for unit system I can use SI, and then click to next. The analysis type, since this is a wing, the flow of the air will be outside of the wing, so I want to use external. If you have pipe system, the flow of water is going to be inside the pipe, so that one will be internal. So I guess Dr. Shukri will be talking about internal more than external. So in here, I guess I'm gonna, in this application, I'm gonna use external. Then I'm gonna click next. So for the fluid, I'm gonna expand on gases and double click on air. So the project fluid is air, and air is one type of gas. Click on next, and then another next. Here will be the input. I want the speed of air to be flowing from, this is the front part, so it's going to flow from here towards the back of the wing. So it'll be, here will be the entrance, and back there will be the exit. So this box will be created. There'll be a control environment for the wing to operate. So take a look at the X, Y, Z axis at the bottom left corner. And so the flow of the air will be in the negative X direction. So I'm gonna click on that and maybe give it a negative 30 meter per second as the speed or velocity for the air. And then after that, I can click on the finish button and we should be good. So if I want to change the computational domain, I can click on that. I can make it bigger or small. I can turn this a bit, make it a bit smaller in space. Okay. All right, I guess this one make it further. And if you are satisfied, we can go ahead and click on goals. Goals and insert global goals. So over here, I'm gonna click on a couple in the average column for static pressure and maybe even total pressure. Other than that, I want to see velocity X and maybe wall temperature or surface. I don't know. Yeah, Y force. Maybe that'll be cool to see. And I guess, yeah, that's about it. After you are satisfied, you can click on OK there. The check mark, or check sign. And then you can also check the global mesh, edit definition. So settings, can change the size.
Doctor.
Yes.
Mr. Abdul Ghani Jaddur, he tried to join with us in this class, but he cannot. The link is not working with him.
Hold on.
Mr. Abdul Ghani Jaddur.
Abdul Ghani.
Yes,
maybe
he
I have
told
to.
me now. He told me now. He has
with you?
something wrong with the link, I think.
Okay. Maybe I have to approve or something like that.
Maybe.
Let me see how I can do that.
Please.
Abdul Ghani? Naji?
Yes, Dr. Abdul Ghani. Yes.
Okay, Abdul Ghani, okay.
Abdul Ghani is inside now? You have just joined?
Yes, he just joined now.
Okay. So we are good.
Okay.
So back to SolidWorks. Yeah, I'm gonna just use the automatic setting and click on OK there.
Doctor,
Yes.
I want to
Yes.
ask about this exercise. If you don't mind, after we have finished this lecture, can you marking step by step for each one and share to us in the group?
Say that again.
The steps of this exercise, the steps, step by step. Can you mark it each step what we do and share it to us in the group? That's I mean.
You mean in the note, or
Yeah.
because this one I record, so you can get back to it.
Okay, step by step. I mean.
Yeah, that'll be good. Yeah. But yeah, this one I'll make it into a project so that you can explore it, and then you can, yeah. So here,
Yeah, doctor. Okay. Thanks a lot.
can show basic create mesh. So yeah, actually the mesh, I thought I wanted to, okay, so that will be the mesh. Okay, so mesh in CFD will be in the surrounding of the system. So your system is the wing, and the mesh will be outside of it, between in the space that contains the wing. Okay, so that will be the mesh. Then if you're ready, you can click on run, and let's run this thing. This system can take you like one day or a few days or maybe one night. So it can be very time consuming if you are dealing with CFD. So CFD usually takes a longer time compared to the stress analysis. Okay, let it do the calculation.
Doktor, yang untuk flow simulation ni just pakai SolidWorks je
Yang
Saya
ini
pakai
SolidWorks only. So ini macam design phase lah, if I may. So using SolidWorks flow simulation is not maybe it's not the best, but it's fast compared. So you will compare with Dr. Shukri's part using ANSYS. So you will see ANSYS takes a longer time for you to set up. Maybe it's more difficult. You can also do some mistake, but the result, if everything is correct, the result should be very accurate, more accurate than you can expect from using SolidWorks. Tapi itulah, even for SolidWorks it will take a long time to calculate, but it's not like up to 1 hour. So maybe 5 minutes or hopefully less than that. But maybe ANSYS will be taking much longer. but in terms of accuracy, is the trade-off lah. Trade-off. You get with the more complicated system, you get more accurate answer and things like that. Okay. So that's a situation when you are using a computer. There's always things that you have to ask yourself whether the answer that you get is correct or not. So that's something you have to find out. And one of the ways to find out is to use another method. You use another method from the one, or you use another software. So you use another software, and if your answer using one system is comparable or almost the same as the other one, inshallah, I think there is high possibility that your answer will be correct. Okay. So, am I making sense? Do you understand what I'm trying to say?
Yes, yes, clear, doctor.
Clear, okay.
Is it, doctor, this auto calculation in the solid work or something like that? You put the information and it will calculate it like this?
Yes, correct. So, like just now, if you follow me, the main thing is for you to set up in the wizard here on the top left corner. Top left corner, there is thing called wizard. So you follow the step. You set the type of analysis to external. You set your fluid to air, and then lastly you have to give the velocity of the fluid. And the inlet velocity, in this case I use negative 30 meter per second. Because why negative? Because our x is in this direction, whereas I want it to go in the opposite direction to hit the wing. So your inlet is over here, outlet is over back there. So if you can see my arrow there, inlet, outlet. Okay, once you have done that, I guess another thing is to click on goal and then set what is it that you want to see. So I want to see average static pressure, average total pressure, velocity in the x, and normal force in the y. So those are the kind of things that I choose to see. And then the next thing that you have to do is to click run button on the top. So this is very easy. There are other systems out there that are more complicated. You have to touch a lot more things, give input on a lot more items. So far there is no warning, so which is good. So if we mess up something, usually there'll be some warning stating that the system cannot do the calculation. So far we have not encountered that, so which is good. Okay, I think based on the progress bar down here, I think it is almost done. It's almost coming to the finishing line. Okay, so this time is a bit different from what I have been teaching for this class in the past. So I guess in the past I did not really use SOLIDWORKS in my teaching. So but now I think I want to use it. So now we have finished the solver. The system has finished the calculation. So iteration stops at 375. Over there, saying the same thing. So I guess we can close this box or this window, and there is no warning, which is good. Alhamdulillah. So what I'll do is zoom in, hit the space bar, maybe click on that one, isometric. I'll just use the anywho. So what we want to do next, but we don't want to dwell too long on this topic. So I'm going to expand on the history tree. So from the example that I see, we want to be looking at the flow trajectory. So I'm going to click on flow and maybe right click there and click on insert. So once this comes out, I want to be expanding this thing and find which. So I'm gonna click on this right plane so that this will be aligned with this inlet space or inlet direction or inlet plane. So click on that, and this one I want to bring it closer to the inlet plane, but I guess I cannot go beyond that. Okay, just close like that. So this will be the plane, and this will be the domain. So you cannot be going beyond that. So just give it some space there. Then gonna go with line with arrows, and this one I want to have like 300 lines. 300 lines, and we can choose the output here. I want to see the pressure. Maybe I want to see the velocity, the x direction. So that would be cool. And or maybe even pressure. You can keep it with pressure, I guess. Pressure, then click OK, or let it do some calculation, and this will be the thing that you will see. And then I can go here and play it, maybe like that. Isn't that cool? Don't you love that? So I guess from not just to be impressed or to be amazed with the output that you see, but there are things that you can decide whether this shape is good or bad. So you can later on you can decide what improvement can be made. Okay, so it's not just about getting the result, but what can you do with that result? Okay, so that is the aspect that you want to be looking at. Okay, so this is pressure in Pascal. So it was coming in with the yellow color, and then as it hits the wing, this region becomes like green, so meaning the pressure drops a little bit. So pressure drops, and depending on whether the top part what is the reading between the top and the bottom part of the wing. So we will get either force in the X or Y direction. Okay, so I'm gonna stop this flow, and I guess can find out more about this thing as we go on, or as you explore this thing. So I'm gonna just save that. All right, what should I do next? Can also actually I have create assembly. Okay, this one. Here, what I did was to create four bar mechanism. Maybe formally I did not talk about the 4-bar mechanism in detail. So 4-bar mechanism meaning this we have a ground down here, and this is the crank, and this is what we call the follower, and this is the output. So this one I can rotate this way. So this is the crank, and this part is the is the crank. I mean rocker. This one only rocks, whereas this one can turns, and they are connected by pins. So if you look inside there will be some pin. All right, I can click on the motion study, and because I have included a motor here. So here I included motor for the this member, the blue one. So that one can check the definition, the feature. This is the thing, and choose this, and RPM here I set it at 60 RPM. 60 RPM. So if that is correct, I can run this thing. This one was set it to 6 point something, 6.2, 6.15, something like that, or maybe 6.25 second, and then this will be the output. Well, this one is the angular velocity. I suppose for this member for link. So I can check what plot number 5 is. Plot number 5. Check the features. So first on link number 4. So link number 4 is this one, the output link. Okay. So you can trace for one loop or one cycle. Maybe it starts from there, and maybe where does it stop? Maybe it stops somewhere here, somewhere there. So it goes down, up, so until here. So here to here. So that is one loop. So here we have 1, 2, 3, 4, 5. 5 or almost 6. 5.5. Okay, so this is linkage. So I'm gonna click on that, and then yeah, I guess that's about it. So maybe I will show you. But in the test, I think I won't include this thing, but I can also put this in as a thing that you can do in the project. All right. So I'm gonna. And do you have any question on this thing?
Doctor,
we want to ask
Doctor.
about
Doctor,
ask about
Yes.
the test, please, doctor.
we want to ask to repeat this exercise.
Also, we have some question, doctor, about the test. How
Okay.
how will become?
Yeah. The test. I will get to the test in a bit. We are getting there. Okay. But be patient. Yeah. Sabar. Okay. So now I think I can close this thing. Save all. Yes. Say bye to SolidWorks. Bye SolidWorks. So I have to close exit, and then what is next? So what is next? I'm gonna get that out of the way. Yeah. Now we will get to the fun part. So this is something I just shared with you. Maybe it's a bit different from what I shared before, because I guess the one I shared before was missing something. So yeah, let's get down to it. Okay, this one will come in the test. So we have two questions. So this is one of the questions.
Which one, doctor? We don't see anything.
Doktor.
Ya.
Tak tanya. Yang untuk yang robot kinematik ni macam masuk exam ke?
Ya, masuk.
Oh, dia sama macam SolidWorks punya test lah kan? Nak pakai cert dia.
Macam apa?
Cert nak pakai SolidWorks yang ada assembly tu.
SolidWorks ada?
Ada. Sebab saya buat exam tu ada je cert dia. Dia macam assembly, lepas tu untuk linkage, lepas tu kena kira lah berapa dia punya dapat jarak dia semua.
Okay. So boleh skor lah yang ni.
Kena tengok sini lah, lama lah tak usik. Saya dah bukan
Alright.
design dah.
Yeah, because this topic is similar with the topic covered by undergraduate student in the fourth year. So elective, and they call it mechanism design. This is the old code. So now they use BMKU 4363. So robot. So robot is a big topic, but we focus on just one particular thing, which is called the inverse kinematics. And actually there are two, inverse and also forward. So, but we are going to focus on the robot one for the inverse topic. So, robot can be this one, like a toy, or can be industrial, can be something for military or security, and robot can also be for household devices. Nowadays, they also say they have robotic maid. They also have Alexa, but Alexa doesn't just talk to you, or Alexa or Siri. I don't use those kind of things. But I guess a lot of people have this robotic vacuum cleaner. Do you guys have that? This kind of vacuum cleaner? So that has a... Huh?
I don't have.
Yeah, there are many brands out there. Some Chinese, some Western brands, some even Libyan brands you have. Anywho, but our focus is this kind of robot, a very basic one. And also nowadays we have cars that can drive by itself, so that is also considered as a robot. Even in the past, like aircraft has been using some sort of the robot pilot, automatic pilot or something like that. Autopilot. So after the pilot takes off the aircraft, so when everything is stable, so he can push the button for autopilot, and then he can rest or focus on other things. And if you go to certain places like malls or airport, I guess if you remember from KLIA, maybe you see this kind of cleaning device where it is unmanned, so it is autonomous, which is cool. So it doesn't need any human intervention for it to do the work. Okay, so and also this kind of drone. Nowadays, drone are also autonomous, but with certain degrees of freedom. So maybe when they want to do some aggression, they have to be controlled or get permission from human. All right, so in our context, our focus is this kind of robot, and actually this robot and can be simplified with this one, and you can click. So when we talk about this thing, here we have two degrees of freedom, where this the first degree of freedom is defined by the giving theta 1. So meaning the red arm will be lifted or rotated by this angle theta 1, and then the second input or second degrees of freedom will be given by the theta 2 here. Okay, so meaning the blue arm will be rotated as that much. So everything is relative. Relative. The angle here is relative, meaning it's not absolute. So theta 2 here is relative to theta 1. So it starts where theta 1 stops. Okay, so this absolute angles actually is a combination between theta 1 and theta 2. Okay. Okay, so that for those who have taken the class with me before in mechanical system design, like Manish and Arshad. So this is where we are different from previous previous way of doing things. So in the forward kinematics, I guess we tend to more use the absolute angle, whereas in the inverse kinematic we use the relative. This one absolute, this one relative. Okay, like in China, the president of China, Xi Jinping, just left Malaysia after like 2-3 days of this official visit. So China has has championed a lot of robotic stuff, like even autonomous machine. So they say this excavator and truck over here, dump truck, also being controlled by somebody far away from here. So nobody inside the cabin here, nobody inside the cab over here. So, and it needs something that it can respond very quickly, such as the 6G technology. Okay, in the past, I guess if you go read the topic of robotics, I guess Danovic and Hartenberg are two great professors who are very popular with the study of robotics. But I'm not a big fan. I mean, I have not used their techniques for a long time. This is 4-bar mechanism. For you who did not take mechanical system design yet, so maybe you have forgotten what mechanisms are. So basically, if in the machine we have the components or system that move or cause motion, so those are mechanisms. So maybe you have mechanisms to run a car or move a car, mechanism to open the lid, something like that. So anything or mechanism to hold a door. So even inside the engine has mechanisms like the slider crank that can move the piston up and down, and also result in rotation of the crank. So in this is called the 4-bar mechanism. In this for closed chain. So here we a lot of the angles here are in relative angle instead of absolute. So this is the mathematics of it to understand, and H being the homogeneous matrix. So maybe this involves some rotation about certain axis, this rotation about another axis, and this one has also translation. Meaning translation is a movement in linear fashion along X or Y or Z axis. Okay, but the resulting matrix is called the homogeneous matrix, transformation matrix. So if we want to, if we already know the values of theta 1, theta 4, theta 5, I guess we can just plug in those values, as well as theta 1, 2, 3. So plug in those values and then we should get the answers. So basically here we can create this mechanism or this geometry. So we want to check whether we can go from, if we label this A, if I say I want to go from A, this is B, and this is C, and this is D. Okay, A, you want to go to D, C. You want to go to C. So, meaning you should know, maybe we can find this is the theta 1. So this is theta 2. So you have to refer to this. So this is theta 1. This is going to be theta 2, and so on and so forth. And once you know those values, you can find what is the x and y coordinate here for point C. X and y coordinate for point C. So this one is utilizing a bit sleepy. This one is utilizing relative coordinate. So then what we can do here is just copy this thing and run it into SolidWorks. I mean, this is a MATLAB. Okay, let me stop the presentation here. I'm gonna keep that. So is everybody okay?
No,
Inshallah,
Doctor, this
inshallah,
one-
Doctor.
Yes,
Inshallah,
inshallah,
this one
Doctor.
is not clear, Doctor.
So I'm gonna start MATLAB and I've shared you how to download and use MATLAB. Sometimes you have to do this activation, especially if you, like for me, I have not used it for a while on this computer.
Doctor.
Yes.
Sorry, Doctor.
Yes,
Have
yes.
we to download MATLAB?
I already shared you the PDF.
Kau nak kat mana?
Dekat group.
Kau nak kat mana? Tahu aku
Apa
nak
dia?
kat mana?
Okay. Have to sign in.
Paling nak kat mana?
Password. Hopefully I can remember it. And so this one will relate us to this license, which is bought by UTEM. So you can download it and use it on your computer. Otherwise, you have to buy, and that is going to be very expensive. So can put my name here, Anwar. ANUAR, or just Sam. Activation complete. And where is that? Where is MATLAB? Do I need to click on that again? Or maybe I have to wait. Or should I click on that again? Checkout free. Okay, maybe my it was my caps lock was on, so yeah, caps lock was on, so my password must be incorrect. So how do I check this. How do I rectify that? Okay, I can do that, but waste my time there. I guess another way is for me to use what I call online MATLAB. Online MATLAB. So I can also use that. So in the lab, I'm not so sure whether we are supposed to have MATLAB, but if not, we can still use the online version of it. So let's wait for that to come out. Yeah, my caps lock was on, so maybe the password was wrong. All right, so here click on MATLAB Online. I'm going to pretend that I'm in the Donald Trump's land. And then I'm going to open MATLAB Online. Supposed to ask me to sign in. So this time I better, so I have to register. And if you want to use MATLAB Online, make sure you register using UTEM's email, so that they know that you are student.
It's used by
email.
number.
I think it's better. Yeah, I guess so. So I guess I have saved mine here. I'm gonna use that password. Hopefully this is correct. So this password is supposed to be the same thing if you install on your own computer. Just remember that. But using install version and the online version is a bit different. But I guess they have the same capability. It's just that if I'm not mistaken, the online version maybe gives you about 90 minutes if you in one session. If you want to work on something, you have about 90 minutes to use. I guess after 90 minutes, you can restart it and use it again or continue your work. And the good thing is that you can save your work, and like me, but this one I will be in the cloud. So you save it in the cloud. So here, after I'm inside this one, I'm gonna click on Open MATLAB Online. So in the test, I think I'm gonna allow you to bring your notes. Bring your notes. You can open. You can copy and paste from your notes. Especially the calculation if you want to do by MATLAB. So that will be much easier. Much easier. So over here you have Home tab, Plot tab, Apps tab, but I guess we are just going to be using the Home tab, Home folder here, or ribbon. Now over here on the left, we have a column for files, name of the files you have used or recently used or available for you. This is where you do the calculation. For example, if I put 1 plus 1, 1 plus 1, and hit enter, we're supposed to get 2, correct? Is this correct? Must be correct. So when we got answer in the workspace region on the left, we have a name of answer or ANS, and the value is 2. So this value is 2. If I do another calculation, just 9 times 2. Okay, that star is times or multiplication. Hit enter and the answer is 8, because I did not give any variable, so it'll give the variable ends. So and then it will replace for anything that has the same variable. However, if I put a equals 3 times 9, so we have the answer of 27. A equals to 27, and now we do not replace the value ENS, but rather we have A equals 27. That is the value stored for variable A. All right. What else? So this is called the command window. So you can give command like this one, and then this is also the place where you get your output. Okay, command is the arahan in Malay, called arahan or instruction. So we are instructing AutoCAD or MATLAB to do some calculation. Okay, so other than that, we can clear this space. I guess the command will be CLC, and if I put A and then hit enter, here we still remember, the system still remembers that A has a value of 27 because of here. So if I want MATLAB to forget about the old number or previous number, so I can say clear. Okay, so workspace will be deleted or cleared, and if I put A there, hit enter, so it doesn't remember the value for A anymore. Okay, so to erase the whiteboard, click CLC. Oh, it's very sleepy in the afternoon. We just feel sleepy. Okay. All right. But today, yeah, I guess let me just focus on this thing. So from the slide, not this one. Which slide? That one. From this one. So from this one, we can just copy this thing. How to copy? Or Control C, and bring it not to here, not to the command window, but rather click on new script.
Yes, new script, Doctor, in the MATLAB. And
yes, new script.
that's it. At enter, it will be calculation alone or something like that.
New script, yeah, correct. So I'm just going to paste Control V, and what else? What else here?
Save it, then press run.
After Doctor, after Control V means enter or another steps.
No, Control V will paste this thing. Paste this
I
thing.
know
So-
it's for pasting, but after paste, what we will do? I mean,
Okay, let me think. So over here, if I click run, it will run this thing, but maybe I have to give it a name first. Save as. So what was this all about? This is about forward kinematic planar four-bar mechanism. Forward, let's call it forward. Give it a name. Forward FWD kinematic, forward kin, and save it. And then I can just run this. So the command window is down here, whereas the script is up here. So it shows step by step. This is the homogeneous transformation matrix. Okay, so and this is going in both two direction. So meaning you can go from A to C, either go A to B, B to C, or you can go A to D, D to C. So that's why you have two directions. And here if you go from the one route, you get smiley A, which is C, point C. Using the first route, the answer will be 165, 153. Whereas using the second route, smiley B, the answer 165, 153, but the back, I guess in the decimal places, it's going to be a bit different. So they're not exactly the same, but all very, very close, in close agreement. They are very close, in close agreement. Okay, so this is for forward kinematics. So if you need it, you can just copy it and run over there. But what was the input here? What was the input? Okay, let me try to understand here, try to recall. Okay, those are in symbolic. Okay, here the input, so 15 if is theta 1, 105, theta 2, negative 90 is theta 3.11, and so on and so forth. So on and so forth. So that will give us this thing, and if you draw this thing using CAD, you will get this as the output. So which one, A or B, will be close to this one? Answer in CAD. So I guess using, yeah, they are both very, very similar. Okay, so that is forward kinematic, and then the next one is inverse kinematics. Here we look into the robot thing, and Also, the situation will be like this. 3R. So if you calculate from the bottom, this is a revolute join, R join. This is another revolute join, pin join, and then this is another revolute join. So altogether we have 3R, and so you have to measure the angle relative to the link before it, the previous link, except for link number 1, because you have to refer to the link number. Sorry, this is link number 2, so you have to refer to link number 1, and in this case, link number 1 it will be the ground. So this one will be like absolute, but this one is not absolute. Neither is this one. All right, open chain. So this is our focus. So open chain FK is a forward kinematic. So here we already know the angles. So T1 is theta 1. So theta 1 is 75. Theta 2 negative 105. Theta 3 30 degrees. So all 3 angles are known. Then U and V will be the base, the location of the base. So in this case, this is our U and V, and it is at 5,2. U is 5, V is 2. And then the link length, you have R1 is 8 meter, I don't know. So this is 8, this is 10, and this I don't know, like 2. Uh, 8, 10, and 2. So what I'll do is in this case it is for inverse kinematics. So you want to find what value. So we have simplified this thing. You can follow these coefficients, and that will be good. So the coefficients are A, B, and C. So there is C is a bit long. So what you can do is you can just copy this thing and then run it in MATLAB. So in inverse kinematics, basically, if I use, so I'm gonna reduce this or minimize that. So the next tool that I want to use is AutoCAD. But for your test, you do not have to use that necessarily. Where's my AutoCAD?
Doctor,
Yes.
in our test, we just will use SolidWorks, or both of them, SolidWorks and MATLAB and AutoCAD.
AutoCAD is optional, but I guess I will try to make you use SolidWorks and MATLAB.
Doctor,
SolidWorks. Yes.
please, MATLAB, it's so hard. We don't use it before, and now
Okay.
we are so shocked with
Okay,
when we see
that's why I do not ask you to do it yourself. So you bring your PDF, so you copy and you get to know what to change. So that's about it. You must know what to change. Okay, even this one, AutoCAD, I have to sign in because I have not used it for a long time. One-time password. Okay, so this is something new. Okay, this one you have to register with them and see after that maybe you can only download the software. Sign in. So am I signed in or not? So many things asking for verification and sign in. So sometimes you tend to forget the password. Okay. So I think I can start a new one. Okay, so let's say if I want to create something from the. So have you used AutoCAD before? If not, don't worry.
Yes. Dr.
You
I
use
used it to AutoCAD. I used it to use.
Okay. So this, if you learn slowly, I think you can get it. But you are not required to use it. But if you want to learn, I guess it's a very good tool to help you in your work. So here,
Okay,
I'm gonna, because this one is very easy CAD. Okay, so back to our this one. The machine is 8, 10, 2. Okay, I'm hearing my own self. I'm gonna start from 0, 0, and this thing is 75. Then that is 105. 10. Then 30. 75. Okay, so I put 8, 75. Click on that. Okay, so 8, and the angle is 75. So I'm not sure whether this is correct or not. Can check text. So check the angle from here to there. So that is 75. Then the next one will be 10. Or can just create the line. Okay, so here I guess I can go to parametric. Parametric, a line here, a line go there to here. So that is it. I'm gonna hit enter on that. And I guess these two must also be profile one. So back to parametric. So this one is 10. And the last one is 2. So this one is 2. Okay, and then I can go here, there, and there, until I get a blue dot there. Go to, what is this? Coincident. Okay. And then can for this part can say this is part of the ground. So I'm gonna put two padlocks there so that it won't turn, as well as this one attached to it. All right. So if I put angles, so this to here, I want it to be 75. Hit enter. Then this one to here, 105. 105. And this one is 30 degrees. 30 degrees. $30. Okay, this one should give you 17.7 and 4.7. 17.7 and the other one is 4.7. So you go to utilities ID point, that so okay, what is wrong here? Let me check. Okay, so this seems correct. 2 and 1. Okay, what did I do wrong? This is 105, 75, 30. But my answer is a bit different. Oh, okay. This part. Okay. Have to move this thing. So the base is at 5.2. Whereas over here I'm at so I'm gonna close this thing, delete this thing.
Doctor,
yes.
last steps I don't understand how to do it.
You don't understand the steps?
The last steps which you did now.
Oh, okay. Because I had this padlock. So actually the problem arises because here my 00 is here, but the bottom of the base of the robot is supposed to be at 5.2, and because 00 is over there. So that is the problem. So
Doctor, you means to take point line from the 00. Means to take a point line from 00.
Yes, correct. So the base is not supposed to be at 00. It's supposed to be at 5.2. So I'm gonna try to rectify that. So maybe I move this thing from there to 5.2. So 5.2 is there, and then I want the parametric, this part to be fixed. Again, take another padlock and put over here. So now if I check the coordinate over here at that end of the tip, so this is 17.7 and 4.7, which is same over here, 17.7 and 4.7. So that is using AutoCAD to see this thing, and this is the angles that will enable you to go there to get to this 17.7 and whatnot. But in inverse kinematic, you are given the coordinate, and then you have to find what are the angles. So you have to copy this thing, but if you have to do calculation, maybe there's also an example of how to do the calculation by hand. So here, I'm gonna just copy this thing and go to this one, maybe create another one. Escape, control Control V. Okay, that's about it. And guess over here I'm gonna put CLC close all clear. And give it a name. So this will be inverse kinematics. And we can and hit OK. So here the input are given here in this line number 12. U is 5, V is 2, R1 is 8, R2 is 10. Okay, so now is the input. X is at that 15.7. I guess it's supposed to be 17.7. 17.7 and 4.7. Okay, so let's see if we can get the answers correctly. So I'm gonna run this thing. Okay, so you have to, this one is blurred, so you have to see whether you want to use theta 1a or theta 1b. Okay, so let's see what makes sense. So this one is a bit different. So I'm gonna go with theta 1b. So create calculate those points. So let me go back to AutoCAD, see what I did wrong. And, yeah, thought I had AutoCAD open somewhere. Okay, that's AutoCAD. 17.73. Okay, so I'm gonna copy this thing. Copy. So line number 12. So I guess that's about right. But why my answer is wrong? R1 is 8, R2 is 10, UV 5 and 2. Okay, let's check a couple of more things.
Doctor,
Yes.
I want to ask, these answers R1 and R2. When you drawing, it's you already find it answering in MATLAB. I mean, when you draw, how do you find R1 and R2, X and Y, something like that?
Okay, R1 and R2, you must specify. You must specify. The only thing that we are supposed to be looking are the angles. Angle 1, 2, and 3. Okay. 1, 2, and 3.
Means how the angle, it's 75 degrees, something like that, for each angle and calculated.
Yes. So when we...
But excuse me, doctor, I confused a little bit. Because many steps to calculate and many steps to drawing, you know, and it's following each other.
Yeah. I don't blame you.
You have to make a feed more than one videos for explanation, doctor, to understand it. So because you know many steps and making my mind confusing. How to can I do that?
Okay.
Okay, no problem, doctor. Now complete this exercise and we can explain more.
All right. I will hopefully share more when as soon as possible if I...
Okay,
so,
complete, doctor. Okay, inshallah.
Clear all is wrong.
This one, clear all means to remove all or something like that for the steps.
Yeah. Hold on. Let me check one thing. D H slide. Okay, this is more recent one. So got this one. $15. Okay. I'm gonna copy this one. Copy and go to MATLAB. And paste that. Okay, this one. So here actually I wanted to, this the big X, the big X, big X. So we have R3 actually. R3, there will be 2. So we have R1, R2, R3, and from the slide, where is that slide? There's so many things down here. So where is my slide? So say from this one. Inverse. Okay. So yeah, in page 26, when you have this this figure, do you have this page? Maybe it's easier. So here you have R1, this is R2, and this is R3. So R3 must be included. So this is how you calculate x, small x, and big X will be the ultimate end position or endpoint that you need to grip. So you need to grip that very end. Okay. So this is the calculation that you need to do. So this you bring your own. Either you want to refer to PDF or you want to print it out during the test. That's fine. But when I give the position in during the test, it is this big X, this big X. So I'm gonna, but what is important is this small x. So from this big X, you want to relate to the small x and y. So it'll be x or y minus R3 times cosine theta phi times phi or the big alpha. So
Doctor.
Yes.
Sorry, in like this one, we have to solve it in MATLAB or manual.
Okay. You have to do manual. So in the slide, there should be an example how to do it manually. But you have also MATLAB, and you can run MATLAB and see if your answer manual calculation and MATLAB is the same. Because I don't expect you to do the using AutoCAD, because maybe I don't have the time to teach you AutoCAD. So here, this one need to have X is going to be big X minus R3 times cosine of theta. That's big theta. Okay, so that will be the small x, and the small y will be big Y, I guess, minus R3 times, I guess, sine big theta. So put the semicolon. So here I'll change that to the big X and big Y. Okay, this one should be 17. Okay, so now if I run this thing, okay, okay, in here I don't see. So usually you are going to click on the theta 1b, theta 1b. So here it'll give you theta 1 equals 75, theta 2 negative 105, and theta 3 is a positive 30. So which is agree with this thing. So this one is going clockwise, counterclockwise. The angle counterclockwise 75. So this is a positive. This one goes in the negative and clockwise, which is a negative value. Okay, so always remember if the direction, which include the direction of angle, if it follows clockwise direction, it is negative. So if it is following counterclockwise, it is positive. So here, if in this case this thing is pointing, the n effector, the very tip here is facing east, facing Japan. So this is 0 degrees. 0 degrees. Going north is 90 degrees, west 180 degrees, and south is 270 degrees. Okay, so that's the convention of direction that we use here. Okay, let's take a look at another example. Okay, I guess so usually if you run this thing, when it asks which theta 1, because you can get two set of answers, so two sets of answers, but both can be correct, but one usually you want one of it. You want one of it. So for example, why can we get two? If I click here, I choose theta 1a. I don't see the. We're supposed to see the. Okay, I understand. So we have a different answer. So we want to see theta 1. So theta 1. So this one is not showing. So we are supposed to be seeing this thing, these values. Anywho, maybe I can make some modification here. I'll just type theta 1b, theta 1a. I'll make the b first. B is first one a. Okay, so yeah, it doesn't show. I mean, supposed to be able to see it, but I can't. So yeah, but you more often than not you want to use B. But what if I choose A? I choose A. Here my theta 1 will be 313.52, and this will be basically theta 2 negative 255, and theta 3 negative 58.5, which is not nice number, but you see, if I follow that, where is my AutoCAD? So this one I want to put over there. This one, can you still see my okay, so I can change this to 313.5213. 313.5213 goes that way. So angle this angle theta 2 is negative 255 or 254.99. So I'm gonna say 255. And why does it negative 255? Still going that way. And the last one is negative 58.5214. So if I check what is the ID over here, so yeah, it's different. Yeah. But I guess actually it's supposed to be able to still get the same place. Maybe this one needs to go the other side. I can change this to negative 2. Okay, or maybe negative 255. 360 minus 255, that's a positive 105. So that's supposed to be positive 105. So 105 positive. 105. So 105 positive should be in this direction. So yeah. So if can we delete that, then turn this thing away like that. And then do the parametric from here to here and make that 105. So if I check the ID here, that should be 17.7 and 4.7. So what I intend to show here is that actually both using either the first choice or the second choice should bring you to that position. But you are going to, one is going to go up, the other one is going to go down like that. So two sets of solution can be achieved. Okay, so this is correct, but you need to be able to. But there are going to be different numbers now. So I guess the other solution seems to have better numbers. Better numbers. Okay, so in inverse kinematics, you are given the destination, but the way you get to that destination can be maybe two. There are two ways to get there. Okay, so you are finding the theta 1, theta 2, and theta 3 in order for you to get there. Okay, so the equation that you need to follow will be this equation. I'm not sure whether we have this in the other. This is some verification.
Doctor.
Yes.
The
Yes,
equation we will calculate it by manual.
Yes. You calculate by manual. So you just like this example. This example shows you the calculation. Okay. So this I'm not sure in the version that I give you whether we have this or
Use
not.
sine and cosine by calculator.
Yeah, correct. So hopefully you have the scientific calculator. Do you have scientific calculator?
We have normal calculator, you know. To ask doctor today me confused too much because many equation and many steps and by SOLIDWORKS and another apps.
Also me, doctor.
Minitab.
Minitab? You want to use Minitab?
No. I want. We want to use the easiest one. No, you know, doctor, because long time we didn't use the computer.
Yes, doctor. Okay.
What's the easiest one? Sorry, doctor. Can you explain to us the easiest one for us, for the students? You know, because now we're confused. There is a different methods. You know, different methods about the steps for drawing and for calculating, something like that. For the Minitab and SOLIDWORKS, you know.
Yeah.
My mind now confusing. After lunchtime, confusing. You know.
After lunch, you had shawarma?
No. Rice with the meat. You know. Rice with the meat.
Okay. What meat? Beef?
No.
Okay.
Cow.
Oh, lamb. Oh, okay, that's good.
Lamb, yes.
We call it kambing golek here. Kambing. Okay.
Now with the you know confusing my mind, it's well confusing all the steps how to calculate y and x, a and a b, r1, r2, r3. You know.
Okay.
We want the easiest program.
Okay. First of all, you
to share the videos for us.
Yes, I will share this video. You can look at it again and again.
I lost many from the beginning.
Okay.
No, you know, doctor, I lost many steps. You know, in the first
I know.
Then
Unfortunately, there are many steps. So look at this figure. You are given this information. Okay, because this one is a calculation by hand. Okay, you are given this information X, Y, and this is your robot. So what you have? Yeah.
Is this just one page, or the solution has many pages?
Has many pages.
Oh, I think it's just one page.
Okay, I will share this again with you. If the version that I sent to you might not have this page, I will share it again. So this information is given to you: R3, R2, R1, UV, and also this one. xy, and also this one, big phi. So there are three things that you need to find out. So the theta 1, theta 2, and theta 3. So those are the three things that you need to calculate or determine. Okay.
Excuse me, doctor.
Yes.
This is equation for the to find in small x, small y, a and b and c. After when defining this characters, we put it here to find the theta 1.
Yes, over here, down here.
Where?
Here.
Theta 1 and theta 2 and theta 3.
Okay. A few minutes, Abdul Karim.
This one, right? But it depends. When you calculate A, you might get A positive or negative. So if positive, use this top equation. If negative,
yes, I know. I understand you, doctor. I understand you. But here is instructed. This is without number. When we the real exam, to give it me the R1, theta, R1, R3, phi. This is the number, huh?
Yes, of course. There will be numbers.
After that, I put it here in this equation. When we get x, small y, a, b, c, put it in this equation. After that, I make a compare. If a greater than the 0, we use this equation. If a less than the 0, use this equation to get theta 1. That's right.
Yes. Santa.
After that, how to because this is not full pages. You how to put theta 1, theta 2.
Okay, this is theta 1. The next page will be theta 2.
Okay. That's a question. Oh, really?
Okay.
Okay, theta 2. After that, theta 3. Okay, doctor. The next here, my friend he confused after this step. When we get theta 1, theta 2, this is the final answer or what?
Okay, this is final answer. This is final, almost final answer. This is almost final answer.
We can get the full mark here when we get theta 1, theta 2, theta 3. We can get full mark.
70%. 70%.
Okay. Let's show me the next step, please.
Okay.
The next step.
Next step is verification.
Nak tahu kira doktor?
Ya.
Nak tahu kira?
Nak apa?
Nak tahu kira?
Okay. Ada. Tadi mengantuk lah, tapi I think I'm okay now.
Sekarang segar.
Okay, so verification is the next step. Verification. Actually,
here I think we need to make a loop.
Make a what?
Loop for both x1, x2, x3. Okay. This is the real exam. Okay, it's good.
So now we have the numbers. So I guess
yes, I know.
This is the input. Then the information that this final one is facing to the east, meaning the big theta or the phi is 0. 0. So from this information, you can find the small x, small y.
And A?
This one is 0. Phi is 0 because it is pointing to the east. Okay. So if it is pointing to the top, north, it will be 90 degrees.
Because the degree is the same x-axis. Same direction is x-axis.
Correct. So the convention says facing x-axis, positive x is 0 degrees.
0.
That's the direction.
The positive y is perpendicular.
That will be 90 degrees.
Yes, I know.
90 degrees.
Okay.
So, then the next one, after calculate x, y, find a. So here we have a negative a. B doesn't matter, and then you calculate C. So just be careful about calculating all this ABC, and then you decide which theta 1 equation that you want to use. So
the
here,
second, because this is 0, use the second equation.
no, because A is
Negative.
negative. Yeah, A is negative.
You use the second.
Yes, correct.
This is 0.
Yes, correct.
Okay.
So the second one has plus 180, so it's not much difference because this is the only additional part.
Because maybe it's in the third quarter of the geometric axis. It should be added 180.
Yes, correct. Okay. Usually that is the case when you have tangent inverse. So if the the x component down here is negative, so you add 180. 180.
Okay. Here, all of the student is make confused with how to translate this solution to the MATLAB.
Okay. Yeah. So just follow this thing. But in MATLAB, they have
for the make sure about the result. When you use the MATLAB for the make sure about the result only.
Yeah, correct. You can use MATLAB to ensure. To ensure your answers, I guess. Okay. For verification, I guess you can use this one, this bottom one. So once you get your theta 1, theta 2, and theta 3, so you put the last one here. Use this last version. So yeah, let me share this version. So where's my this one?
مش فاهمين شيء والله ما فاهمين حاجة والله.
هذا أمور.
So let me.
ما كلمتكش باش تقول لي نظم امورك يا محترم.
Share. Maybe the previous version doesn't have some information. So what I want to, for the verification, you use this one, this version. So once you have the theta 1, theta 2, theta 3, you have your UV, plug it in, and then you should get your answer. You should get your answer. Okay. For example, let me try show you in the where's my MATLAB? MATLAB, come on, where are you? No, this is not MATLAB. Oh, there you are. Okay, this one I want to be on that side. So here, if I want to do the verification, so R verify equals U and V. So I use the square bracket U and then semicolon V. So this one plus R1 times then this one cosine d theta 1. So what theta 1, and then semicolon sine theta 1. Okay, I guess I can just copy this thing because the rest are going to have pretty much the same thing. Copy that.
ما تركزش فيه الماتلاب يا احمد، الماتلاب بياكد بيه النتائج بس، هذا هو زايد هو.
So MATLAB
مش حيطلبه منك الامتحان، مش حيطلبه منك الماتلاب اهو. هذا اللي فهمته منه.
this one is theta 1 plus theta 2. Theta 1 plus theta 2.
تمشي الامور.
Plus
ما تركزش فيه هو، ما تركزش فيه يا احمد، الماتلاب هو البرمجه هذه الفهم، ما تركزش فيها، مالكش علاقه بها، يا هيك فهمت منه. هذه ديرها كوبي بيست في البرنامج وتاكد من النتائج نتاعك، مالكش علاقه بها.
Copy that. So since we're not having enough space there, it's going to be too long. So actually can cut this thing. How to cut? So this one I cut this thing and put triple dot, and then put theta 2 here, then plus, and then this last one will be for theta 3. So this will be for theta 3. Or maybe leave over there. I guess this one is cool. Plus dot dot dot. So this part will be theta 3, R3, and we have theta 3. So follow this pattern, theta 3. So when we do this verification, if I put this symbol, maybe I don't have to, or maybe I can go here, run section. So when I run that section, will give me this answer 17.73 and 4.72, and this is basically our input. Okay, so when we get our input back using the theta 1, theta 2, theta 3 that we choose, that means our answer should be correct. Any question?
Doctor,
Yes.
please go back to the pages that data 1, data 2 with the numbers and show us this number come from here, this number come from here. And in the exam, we will give you this number, this number, this number, and you what we have to find.
Okay,
You understand
this
me?
one.
Yes, yes, this one. X small. Is it? No, no.
This one.
Yes, this one.
Okay.
In the exam.
So in
For
the
example, doctor,
exam,
sorry, doctor. Sorry.
Yeah.
For example, in the exam, you give us like this shape, okay? For example, and what numbers that you will give to us, and what we have
I
to
will
find.
give this one,
Okay.
this one,
What's name of this one?
and this one.
The names of this one.
This will be okay. I need to tell you everything.
Okay.
Okay, let me say this one. So this is big X, this is big Y. Okay, this will be
Okay.
U, small u, This will be small v. Okay, and then we should know this is R1, R2, and that will be R3. R3.
Okay.
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 So this is something that you need to find. So this is question mark. This is what you have to calculate. Okay.
Yes.
Yes.
Okay.
Yes.
And actually, another thing is phi will be given, phi or big theta. So in this case, phi is 0. So not every case will be 0. So why is it 0? Because it is facing east. So that's why phi is 0. Okay. So this is the n effector. They call it n effector. The final of the direction of the ending or n effector. It's hard to to write using the mouse. Okay, so all the rest you have to calculate. So based on that, you have to calculate. So you have to calculate small x, small y, a, b, c. Then only you can calculate theta 1, where's theta 2 and theta 3. Where's that? Theta 2 and theta 3. So after you have calculated theta 1, theta 2, theta 3, you go here. You do this calculation. It's called the verification. So you can also use this one, but it's going to be much longer. So using this one is much simpler. Okay. So if you stop here, I'll give you 70%. Okay. If you, this one is another 30%. Because we engineer, we should not just do, but we need to know whether what we are doing is correct or not, is right or not. Okay.
Doctor.
Yes.
Doctor. Sorry about
Yes.
this question, but you will focus on the final solution, or will give us some points about the steps?
No, I won't tell you the steps. You should know the step.
Yes, step and final
If
solution is
you do the verification and you get the big X and big Y, so that means your calculation is correct, your work is correct. But if you do the verification and you do not get this X and Y, then something is wrong somewhere. You understand?
Yes, I understand.
Okay.
Inshallah.
So that's the good thing about verification. So if you get it, then you know if you are correct or not. Okay? I don't have to tell you the answer.
Doctor.
No, doctor. Excuse me, doctor. He means my colleague, not you told us about the correct solution. He means if our steps it's correctly and the final solution or the final calculation it's not correct, wrong means it will be good mark or not. It will be commonly wrongly.
Yes, that's what I mean.
It won't be if you got the answer wrong, then it won't be full mark. I cannot give full mark, but I will give some mark if the you have the correct way. Maybe just some mistakes here and there. So don't worry about mistakes. So it's not, you don't have to be perfect about it. Don't be too worried about this. As long as you be careful and use the correct equation, I guess that will be the main thing, the main focus of this exercise. Okay.
Yes, that's what I mean, because we have to. We have a long time. Don't use a calculator, so we hope to use it successfully.
Inshallah, there is time for you to start using the calculator. So, inshallah.
Calculator will be calculator, doctor.
Yeah. You have, if you don't have, you have to go to the store and buy one, a good one, or you use Shopee or Temu, whatever. I guess there are a lot of good calculators. Usually Casio will be good.
Give names,
Casio and
doctor.
Flamingo. It's the best companies for calculators.
Give names.
What Flamingo? What brand is that? And another brand will be Texas Instrument, I guess. Okay, I guess from here, and then the next question will be this one. So, well, I'm supposed to finish at 5. What is the time now? Okay. Okay. If we can finish this thing, I guess that'll be good. Okay. The next one is this one question. So, for second question, focus on this one. So it says determine the displacement. So this, you have two materials. One is between A and B, and the other material between B and C. So this is from mechanics of solid mechanics or mechanics of materials. So this is using one material. The other one is another material. So when you pull, you give a force of 60 kilonewton. You want to find what is the displacement of C with respect to A. So yeah. So this is the situation that will be for the next one. So there is also YouTube, so you can also click on that if you want. But basically, we can also use MATLAB to do the calculation. But these are some of the steps that I put it in MATLAB so that you can run in MATLAB. But basically, okay, I guess yeah, I guess the focus will be for this one. This will be the second thing for you to solve. But you know what? The answer will be this one. Del FEA. Okay, this you can also look this equation. You can also look at I guess chapter 2. Chapter 2. Where is chapter 2? Chapter 2. Slides. Yeah, I guess this one. I guess you have this one that has the elephant mesh over there. I guess that step is also shown here. The equation. Let me. It's further down the road. So where are you? Thought I saw it. So these are some of the theoretical calculation that can be done. Okay, I guess you can look into this system of two springs. So basically, like in page 71, so it's kind of like having the for the first material using one spring, and then the second material using the other spring. Okay, so you can look into this steps. These steps. Okay. Is there another one? Not on stiffness matrix. Another set is this example. So you have this part using one material, and the other part using a material that is 2 times the other material, 2 times in terms of elasticity or Young's modulus. Okay, and then it is being pulled just like in that question. So this is on page 81. So you look into how the elements are be broken into two. So you have U1, U2, and then the other part will have a U2 and U3. So this is the basic calculation of how the finite element calculation is being done. So this is the easier example. Easier example, one dimensional. Okay, so first you have to calculate this thing, F1, F2. Then you combine. Okay, you have F1, F21. Then you have F22, F3. So you calculate as such, and then you have you combine them to form a global equation. Okay, and now you have a 3 by 3 matrix, and you basically want to solve for the u's, U1, 2, and 3. And here U1 will be in the U is the displacement. U is the displacement. You can relate to the del, and at the very end where it is cantilevered to the wall or attached to the wall, so there the U will be 0. And then you do all this other calculation, and then you can solve for U2 and also U3. And F1 can also be calculated in this way. Okay, so and then you can calculate the strains, and then you can calculate the stress. Okay, strain is like this, and then stress is just sigma equals to E, the Young's modulus times the strain, or equals to P over A. Okay, so that is the situation. So please look at pages 81 to 87 to understand this problem. Okay, before I stop, I'm gonna. I guess the plan is I want to open SolidWorks again. In SolidWorks.
Sorry, doctor. Doctor.
Hello, are you there? Hello?
Doctor,
Okay, you're there. Okay.
can I ask a question, please? Sorry.
Okay.
So on our final test, you hear me, doctor? Sorry.
Okay.
Hello.
Yes, I hear you.
Our final test, it will be 2 questions from you, huh?
Yes.
One question is calculation and the other question, both of them calculation, or one calculation and the other drawing in the computer, or what?
Okay, I guess this one is should be easy. Should be easy. Yeah. Just the calculation. This one should be calculation.
And it means 2 question calculation, doctor.
Yes.
2 questions.
2 questions. Yeah.
Maybe more, doctor.
There is no drawing small shape, doctor, to help us. Calculation is so difficult, doctor.
Okay, so you like drawing?
No,
small, not very difficult shape, doctor.
Small drawing, doctor.
Small drawing. If you want drawing, I can give you drawing. Yeah?
No, maybe two steps or 3 steps just.
We hope that, doctor, because the calculation is so difficult, doctor.
Yeah.
For example, the last lecture that we take, some drawing like that one.
I see. Yeah, we can. Or maybe this second one, instead of calculation, we can do this thing. So, okay, what I'm plan to do in this exercise before we stop is to see if we can model this thing and compare if our answer here is correct or not. So here we have the displacement 0.48 and 0.93. So here the answer will be A for C, measured from A, but for point B it can also be solved, which is 0.48. So, and what else? So how to draw this thing? So let me draw this equation, this problem as a diameter. What is the diameter? Diameter, or just the area? Area is 500, and the other one BC is 200. The area. So this is a what do you call this? Circular cross section, and circular cross section. So this is 100 and 200. Okay, just like in the other example, or the other slide. So I'm going to find what is the radius here or diameter. So 500. So the equation for area for circle is what? Pi d square. Pi d square, right? Over 4. Pi d square over 4. So if I want to find r, it will be a times 4. So that 500 times 4 divide by pi, and then take the so it should be about 25.23. 25.23. So let me create a sketch. So maybe from this plane. Okay, so don't forget to change this. So what unit was that in? mm. So mm.
Doctor,
Yes.
about this one, how we can find it from the drawing? We find all the dimension by millimeter. That's
Yes.
mean
Yes. Here, I guess in the drawing, here is this one. 500.
Yes.
You have to find the radius or the diameter. So so you have what a equals pi d square divided by 4. So you find what d is. So d should be 4a divided by pi and root sum square. Okay, so if you do that, and this one should be about d a b should be about 25.13. Whereas for the second one, 200. So you have 200 times 4 divided by pi. So 15.95 or about 16. So 15.96 d BC should be about 15.96. Okay, so that will be in mm. Yes.
So on real exam, you will not give us the diameter.
I'm not sure yet. I haven't done created the sualan, the question yet. So how to do this one?
Okay.
This one. So the diameter. So this one should be 25.13. Then and the length is what? 400. 400. So extrude 400. So this material is having what is the material? EAB is 100 GPa. 100 GPa. 100. So I don't know what material that is. We can certainly look here. Edit material. So this is hello. GPA
Yes.
is giga. So giga is 9. 9. So 9 then 3. So wonder what material this thing is. 2 1.9. So maybe something soft, like copper. It's 1.2. 1.2. 1.2. 120. This is 100, almost 100. Almost 100 GPA. How about this one? That's too soft. Okay, how about iron? Okay, so yeah, we can choose like that one and the other one. Or can we custom material, plastic? Okay, models of elasticity. Okay, this is almost 105 copper. 1. So this is exactly 100. Okay, that is brass. Brass. So I guess so. The first one is supposed to be 100. So I guess we can use brass, apply, and close. So this is brass. So I guess we can save this. And guess I can create another file, new one, also a part, click OK. And go to sketch, also this one. So here, okay, I always forgot, change this one, the MMGS, now sketch, okay, sketch, this one. So this one has a 15.96. Then turn this into what? 300. So this one 300. Okay, and then for the materials, you want it to be about 200 GPa. 200, so this is close. This is closer. This is exactly, so this is a 1010 still. So let's use this one. Close and save this. So next, I want to create a new one where I combine, assemble. I assemble. So this is assembly. So I want to create using AB first. So create AB. I want to hit enter. Don't put it anywhere. Hit enter. And then assembly again. Insert component. Can click on that. Keep visible. Want to click BC. Put it over here. Okay, and then escape. I'll say escape. Okay, now I want to assemble it. So how do I assemble? So go to mate. Yes, can mate this one to this one. You click accept, and then you can pull this out, push it out, and then the next one I want this one mate with this one. Okay. Okay. So now it is there. It is fixed together. Hit the space bar. I guess let's see this thing in this one. Okay. Or I can rotate it. Maybe like this. Okay, and then we have to give the input is 60 kilonewton. So now let's do the simulation. Let me enter that. We can give save this thing. C. Okay. So let's do the simulation, new study, and just accept static external load of fixture first. So you want to fix this and add fixture, add there. So use the fixed geometry type. And then the next one, you want to click external load, rotate this way. Then over here, add load on the right panel. Add load, you want to use the force. This one, this surface or face, and then you want to reverse the direction. And value here, you want it to be 60,000. 60,000. 60,000. 60 kilonewton. Okay. Reverse. All right. If that is done, you click OK. Check it. You have AB and BC, and that is fixed. And you have a load, and just run it. Run this study. Yeah, are you there? So over here, the maximum must be over there, and it's 9.3 or 10 to the minus 1, so that is 0.93 mm. 0.93, which is or you can go to plot, probe. So if you want to probe, put your probe over there. So that is the reading. So 0.93 or 0.94, and over here that is the del, and then over here that will be 0.47 or 0.48. So you can look into if you're doing this using MATLAB, so you can just copy this thing, copy. Go to your MATLAB, paste it, then over here, copy these things. Then let's run this. Maybe give it a name. Stress or del. Find del. Find del. ABC. Find del ABC. Actually, it's more than finding del. So we'll give you. This is the answer, 0.48 and 0.93 for the displacement or del or strain. Okay, so you can try to follow. I have some you know, after the % sign, that'll be the comment. So hopefully some information are given there. So I'm gonna stop sharing, and go. How to get to you guys? This one, and try to turn on, see if you're still there. So hopefully this is a beneficial session for you guys, and I know it's a lot to study. And when I did my master, I was also an old guy. Not too old. I graduated about 3 years before I did my master. And then then my PhD I was a little bit more older. So yeah, being old is kind of like a big challenge too, to when we want to study, but it is not impossible. A lot of people, they are wiser when they are older, and I believe that is what you guys are doing, because even though you have left education for a long time, but you still want to do master. I guess that's a big noble intention, good nawaitu, good intention, and I guess you have a lot that you can dig into to solve the problems, and inshallah I'll share you the latest version of the project. So it's basically should be able to prepare you for the test also. Okay. So the key thing is for you to do some exercise. You can test like that robot thing. Try to move it to a different location. Okay, I will also share you one example, other example, so that you can maybe from previous tests, so that you can see how it is being solved. So it is possible for you to do the hand calculation, and shouldn't be that too challenging to solve. Okay, do you have any question before we stop?
Doctor.
Yes.
As you know, we don't have SOLIDWORKS or any kind of program to study on it. So please send us some video about what you did now to follow you.
Okay.
You understand?
I will share more materials, but the other alternatives is for you to use Inventor from Autodesk, and and actually there's another software called FreeCAD. FreeCAD is also much easier. I mean, much lighter version of CAD. I will also try to share that material later on, but for now, maybe you talk about how to. I will share, inshallah, I'll try to share the project tomorrow, latest by tomorrow, and you try to form the team, the group by Sunday. So you decide, maybe I guess 3 people is enough, or 2 people, even 2-3 people for one group is enough. So that you can have more groups, so that you can participate and contribute more to the project, as opposed to so many people in the team. All right, don't be too worried about the test. I think if you have done it, if you have tried it, the test should be just a repetition. So test is not supposed to.
Doctor.
Doctor, I want to ask also, Doctor, you give us something close to the exam so that we can learn and practice it. And,
sure.
God willing, It will be the same method in the exam with the thanks a lot, Doctor.
Yeah.
You understood
How
what
about
I
if I
mean?
give
You
you
know?
exam?
Yeah. No.
Yeah.
It's,
Sure. I understand.
Yeah.
But yeah, it's not going to be a big issue. I will try to share more information about the test as soon as possible.
Okay, thank you very much indeed, Doctor. About the same method, you know.
Okay, inshallah, you guys don't worry too much. Okay, just keep on learning, and I'll see you next time. And I hope don't forget to come to class next week, because I guess maybe Dr. Shukri wants to see you guys in the lab.
Inshallah, I need Tuesday, inshallah.
Okay, you have to come here, not like this week.
Inshallah.
Okay.
Yes, okay.
Inshallah. Assalamualaikum.
Assalamualaikum. Thank you very much indeed.
And
See you.
Doctor, any information share to us?
Inshallah.
Any something discussing or not understanding, we will sharing to you and ask you.
All right. All right. Arshad, what is it? Yes.
Untuk exam ni, dia pakai software ke untuk dapatkan jawapan yang tak nak kena kira juga?
Ada pakai. So make sure you have access to SOLIDWORKS. We will have the test in the lab. We will try to arrange so that the test can be in the lab. So you can use SOLIDWORKS. Or if you want to bring your and also MATLAB.
Ya, cuma dua lah, MATLAB dengan itu boleh lah.
Yes. So MATLAB, you need to know what to change in the MATLAB. You need to know what to change in the software. Okay. So it's going to be just a repetition if you have done it before, and don't worry too much. Okay. Assalamualaikum. Have a good one. Bye bye.
Okay.
Thank
you, Doctor.
Okay,
Doctor,
thank you. Bye.
Bila nak barai rumah Doktor?
Rumah saya banyak kucing.
Okay, tu. Saya pun pecinta kucing.
Okay. Inshallah, we'll talk about that. Assalamualaikum. Bye bye.
Salam.